The universe is vast, far beyond human comprehension. Today, the observable universe spans roughly 93 billion light-years across. But this enormous volume is only the part of the cosmos we can access, not its full extent. What we can see is limited by the speed of light, the age of the universe, and the ever-accelerating expansion of space itself. These factors not only define what we can observe today, but also set a hard limit on what we will ever be able to see in the future. When we look out into space, we're also looking back in time. Light, even though fast, doesn't travel instantaneously. So when we observe distant objects, we're seeing them as they were in the past. We see the moon as it was 1.3 seconds ago, the sun as it was 8 minutes ago, and distant galaxies as they were billions of years ago. The further we look, the deeper into the past we peer. The oldest light we can detect comes from the cosmic microwave background, CMB, a faint glow from about 380,000 years after the Big Bang. Before this time, the universe was filled with a hot, dense plasma that was opaque to light. Once the universe cooled enough for atoms to form, light was finally able to travel freely. This ancient radiation has been reaching us ever since, carrying an image of the universe in its infancy. But there's a strange twist. Although the light from the CMB has taken 13.7 billion years to reach us, the region of space it came from is now 46.5 billion light-years away. This is due to the expansion of space, which stretches distances even as light travels across them. As a result, we often say the observable universe has a radius of 46.5 billion light-years, the current distance to the farthest objects whose light has managed to reach us. Beyond that lies a vast, unobservable region, parts of the universe where light hasn't had enough time to reach us since the Big Bang. The particle horizon marks the outer edge of this visible sphere, the maximum distance from which light could have traveled to us in the age of the universe. As time passes, this horizon expands, allowing us to see more of the universe. New light is constantly arriving from farther and farther regions. However, this expansion doesn't go on forever. There's a cosmic limitation that awaits us, driven by an elusive force known as dark energy. Dark energy is causing the expansion of the universe to speed up. As a result, distant regions of space are receding from us faster and faster. Eventually, some parts of the universe will be moving away from us so rapidly that light from those regions will never be able to reach us. Not now, and not ever. This leads us to several crucial concepts. One is the Hubble horizon, the boundary beyond which galaxies are receding faster than the speed of light. This may seem like a paradox, but because space itself is expanding, regions of the universe can separate from each other faster than light without violating relativity. The Hubble horizon is currently about 14.5 billion light-years away. Surprisingly, we can still see galaxies beyond this limit because the Hubble horizon has changed over time. It was smaller in the past, allowing light from farther galaxies to slip through before it moved beyond reach. The more absolute boundary, however, is the cosmological event horizon. This horizon marks the limit beyond which no information, light, or signal will ever reach us, no matter how long we wait. It's a true edge of future observability. Due to the accelerated expansion of the universe, this horizon is actually shrinking over time. Right now, it sits at about 16 billion light-years in co-moving distance. Roughly 10 billion years from now, the cosmological event horizon will coincide with the Hubble horizon. At that moment, we will have reached the maximum cosmic volume that we will ever be able to observe. Any photons that haven't already crossed that horizon will be lost to us forever. The last signals to make it through will bring the most complete view of the universe we'll ever have. reaching back to regions that were once over 60 billion light-years away. That final picture will be our cosmic panorama. Even after this moment, light will continue to trickle in for a time, but it will grow weaker and more redshifted. Galaxies will fade into the infrared, then into radio waves. Eventually, those radio signals will be stretched so far that detecting them would require telescopes larger than entire solar systems. Practically, the universe will fade into darkness. What does this mean for humanity? It means we are living at a very special moment in cosmic history, a time when we can still see the distant past, when galaxies are still visible, and when we can piece together the early structure of the cosmos. But this window is closing. One day, only the nearby galaxies within our local group will remain visible. Everything else will be beyond reach, both physically and causally.